Alright, so welcome back to another installment of our workshop series. In this episode, we're going to be building a simple web app to serve our image classifier using Flask. So we're going to be building a web application that serves our image classifier model we built in the previous workshops. The user will be able to draw on the canvas, they can press a button to clear the canvas if they choose to, and they can press a button to submit the canvas so that the model can predict the drawn image on the canvas. The web app will also be able to display the correct prediction of the model. So this workshop is going to be self-contained. It's going to use everything that we've learned previously in the previous workshops. So let's go look at a demo of the finished product. Alright, so here's a demo of the finished product. As you can see, here's a canvas that the user can draw on. If they hit predict, the output comes up at the bottom of the screen. They can also clear the canvas. Here I'm trying with a bunch of different digits. Most of the time it gives us the right value, but sometimes it does mess up. For example, here I think I put in a 0 and it comes out as a 5. But that's an issue with the model and not with the web app itself. But overall, I think it looks pretty great. So for this workshop, we're going to be using a few things. For the server backend, we're going to be using Flask, which is a web development framework. And the reason we're using Flask over something like Express and Node is that Flask keeps consistent with Python. We're using Python, especially with our machine learning model, using Keras, and we have our predict script that we built in the previous workshop using Python. This way, we can just copy over the script and not have to transfer it over to a different language, as well as it keeps consistent with all of the different dependencies that are Python related. For the client, we're going to be using basic HTML and CSS for the web front end. We're going to be using JavaScript and jQuery for the canvas as well as the script logic. And we're going to be using Ajax within jQuery to make HTTP requests. And also, this builds on all the other workshops that we've been using for this workshop. So that includes all the tools and dependencies we've used previously. So here's a general overview of how the program will work. So the client will have an HTML canvas they can draw on. And once the client submits the image, we're going to send that image data over to the server using a POST request. So the server is where the image classifier model is housed. And the reason we do this is because it's really expensive to keep the model on the client side. There's lots of dependencies that are really large in file size. Normally you want to keep your models private so that the clients can't see them and so people can't steal them, for example. And generally when you're building web apps that use machine learning models, you want to keep all your data and models on the server side. So with that in mind, the server will use this model and make a prediction with the client's input in the backend, and then the server will send that predicted digit value back to the client to be rendered. Alright, so before we get started in coding, let's just do some housekeeping chores. So the first thing is navigate to your working directory. In this case, I'm using this as my directory for this workshop. And just make sure you have everything installed from the other workshops in terms of dependencies. So, for example, if you haven't run this command pip3 install flask, which is going to install Flask, do that, but I already have it installed, so I'm not going to run it again. So next up is the file architecture of our workshop. So as you can see right now, I only have a directory called model, and inside this directory we have a .h5 file containing all the data of the model we've trained. So this includes the weights and the features as well as the dimensions. And if you recall from the previous workshops, when we used model.save, this actually saved all the model data into this h5 file that we used to load when we ran our predict script. So all I've done is just copy that file into this directory. So next, how this is going to work is we're going to have our app script, which is basically the server backend, within this directory. But we're also going to have two subdirectories. So the first of which is going to be called public. So let's just make that right now. And public is going to contain the HTML file that represents our server front or our client front end. And we're going to be housing this HTML file in this public folder. And this is something that you really want to do, is have your front end in its own separate folder. You can also call this template or templates. And that's something pretty popular that people do. But our next folder is actually going to be called static. And this is something specific to Flask. So whenever Flask runs, it's going to look for this static directory. And this static directory contains the static files that are going to be used in a web app. And this basically means this is where our CSS files, as well as some JavaScript that are static files we're going to be using, are going to be housed. All right, so with that out of the way, we can actually get started with our coding, and we're going to be starting with our server backend. All right, so here's what we're going to do when we build the server. So first, we're going to create a Flask app listening on any chosen port number. We're going to load in the saved .h5 model from the previous workshop that I discussed. We're going to render an HTML file at the home endpoint, which is just going to be a slash. And we're going to create a /submit endpoint for when the client submits to Canvas. So for this endpoint, we're going to be using get and post requests. We're going to receive the image data from the client in base64, which is just the way that the Canvas encodes the data when it sends it over. We're going to decode that base64 format and save it as a PNG file, save it locally. We're going to load that PNG file up and use the same predict code that we've used from the previous workshop on that image. And then we're going to return that predicted output and then send that back to the client. All right, so let's finally get started on coding. So first, let's go ahead and create a new Python file. Let's call it app. And this will just be the application that actually sets up the server. So let's start off with some import statements. We're going to need Flask, obviously. So from Flask, let's import Flask. And then we're going to need two things, the first of which is called render template for the template HTML file, as well as request. Oops. All right, so next, let's actually go ahead and create the app. So let's create an app variable. And this is going to be equal to Flask and name. And then let's specify the template folder. And then, as you recall, we're going to be using the public folder to house our template. And this is create Flask app. All right, so from here, we can actually create our first endpoint, which is the home endpoint, to render the HTML file. So what we do is we do app.route, and then we call this endpoint the slash for the default endpoint, and then we're going to define a function. In Flask, after your endpoints, you always have to define a function. And so let's define this as render and return a function called render template. And then we're going to use the file name of our template, which is going to be index.html. We haven't actually created this file, so it's going to give us a warning, but we will create this in the future. And remember that because we specified the template folder as public, we can just call this file path as if we were in this folder. So this is going to be the home endpoint, and then we're going to render HTML file here. All right, so next we can actually go ahead and write some code to actually run the app. So run app, and what we do here is if name equals underscore main. Then first let's specify a port number. So port equals, and we're going to grab the port as an integer. And this will be port, and then let's just use like 5,000. And we're going to need to import OS for this. And then we can go ahead and do app.run, which is going to run the app, run the server, which is going to be listening on this port number. And because we're using localhost for right now, let's go ahead and just put all zeros, which specifies that it's going to be the same machine that's going to be hosting the server, and port number equals port. All right, so let's leave it at that for right now. Next, we're actually going to be creating all of the files related to the model in its own separate Python file, and we're just going to bring all the code over into this app and then create the other endpoint, the submit endpoint from there. So let's go ahead and create the Python file that's going to house the model, and let's call this predict. And the reason we do this is just because it encapsulates things and makes it a lot more organized. So here, we're going to have to do a bunch of import statements, which is going to be all the dependencies we've used previously related to the model. So we're going to import CV2, which is our computer vision library. We're going to import NumPy, import TensorFlow, and then import OS, import system. We're going to import base64 as we need to decode the information that the client sends over. And then something we need to do is make sure that we're able to access the model within the directory. So we're going to do sys.path.append os.path.abspath, and then give it the path of our model directory. And this way we can, in this way it includes the model directory, and we have access to the files within that directory. So let's first create a function that initializes the model. So let's call this comment initialize model. And let's define a function that returns the model that we've loaded. So let's call this init model. And then we're going to use a variable to specify our model called loaded model. And then this is going to be equal to TensorFlow.Keras and then .models, and then the function load model that we've used previously, and then we're going to specify the actual path to that .h5 file. So remember that path is model, and we named it classifier model.h5, and then here we go. Here is the model, and then we just want to return that. And then let's create a print statement here just so that we've loaded the model correctly and we can see that in the server, which is helpful for debugging. So let's say loaded model successfully, and then return loaded model. So next, we need to create a function that actually saves the output image that we return from the server. So first, we're going to create a function, and then it's going to take in whatever image data that we get from the client. So right now we don't actually have this data, but let's say we do. And when we call this function, we're going to pass in that data. When we call this function in the app.py file, we're going to pass in the data we've got from the client as a parameter, and it's going to take that data. We don't have it yet, but we're going to take that data, and then we're going to save it after decoding it as a PNG file. So Let's call this function process image. And then let's say the image data is called img. And then we're going to open up a file descriptor representing the image. So with open img output .png, and then let's give it read write permissions, and then let's call this output, and then we're going to write all of the decoded information into that file. So we're going to use this base64 library that we imported, and then we're going to use this function called base64 decode. And this function, it takes in a string-like object. So we're first going to have to cast our image data into some sort of string-like data. So we can use a string to cast, and then we're going to give it our image data, and then we're going to give it the UTF-8 character set, because that's standard. And then that's pretty much it for that function. And this is process image. So this is basically doing decode from base64 and save image. All right. So next, we can actually go ahead and write the actual predict script that predicts the output based on an image. So because we've already written this code before, I'm actually going to go ahead and copy over the code that we've used from the previous workshop. So let's first define a function, and that function is going to take in the model that we use, because we're going to pass in the model once we've called a init model in the app, and then we're going to pass that model data into this predict function, and it's going to use that model data and then predict the output. So let's actually go ahead and copy over the code that we've used in the previous workshop. And this is code that we've written before, so there shouldn't be anything new. And just copy over. And here is all the code, and output is going to be the integer value, the number value. So we want to return that and send it back over. So just return the output. And then here we can go ahead and call this make a prediction based on image. And so here, what I've done is sort of change the image read path to be the same path as we've specified. This is the only change that I've made. Everything else is the exact same. I've also gotten rid of the plot code to like display it, because we don't exactly need to display it. And then, yeah, so let's just reformat that. And then that is pretty much our predict script. And now let's go back to the app script and basically include everything that we've done in that script. So we want to do from predict, which is going to be the file name of everything, and then import all the functions. So let's import star, which is going to import everything. And then right below create Flask app, let's initialize model, and then we're going to use that init model function that we've created previously. And remember that it returns the actual Keras model, so let's just create a model variable and set that equal to init model. And so here we have a global variable representing the model data. And then once we load this in, we don't have to load it in again for subsequent predictions. So it makes every prediction after the first load in a lot faster. So once we have that, we can actually go ahead and create the endpoint for submit. So let's go ahead and app.route and then submit slash. And then define a function. Let's submit as our name for a function, and then First, we're actually going to include this thing right here to specify the methods we're going to use. Now remember, we're using get and post methods. So get and post. All right, so now that's done, we can continue with the function. So within the request here that we've imported, this is going to be the stuff that the client sends over. So let's create a new variable called image data, and we're going to set that equal to request.getData. So this is going to be the data that the client sends over when it calls the post request in this specific endpoint here. So we're going to get this data, and then we're going to call the process image function that we had previously in the predict script, and we're going to call it on that image data. And this is going to save a PNG file locally in this directory. And then from here, we can just actually return the prediction and pass in the model data. And because this prediction returns an integer, this endpoint needs to return a string. So let's just cast this to a string. This is just because that's how it just wants the string to be returned. And then let's go ahead and create a print statement just for debugging purposes. Here we go. So predict with model. Yeah. So far this looks pretty good. Just specify this as our submit button endpoint. And this is pretty much all the server code we're going to use. Actually, now that we have OS imported from predict script, we can just get rid of that. But this is pretty much the entire server backend. So next up, we're going to have to work on the front end, and we're going to see actually how we utilize the post request and how do we get the image data from the canvas. And so this will make a lot more sense when we actually go ahead and create the client. So now that we're done with the server, let's move on to the client. So for the client, we're going to be having this HTML file, this HTML template, and it's going to house all of the canvas as well as the clear and submit buttons. But this canvas needs to be activated with some JavaScript. So in a separate file, we're going to have just a JavaScript file that contains a bunch of code that actually lets you draw on that canvas. Also, we're going to have a CSS file that just includes some styling to make everything look nice. And then within the HTML file, we're going to have a jQuery script written in JavaScript that uses Ajax to perform a post request to the server. And then in this script, we're going to first capture the image data on the canvas. We're going to do a bunch of things to send it to the server. And then we're going to render the output response from the server if that request was successful. All right, so now that we're done with the server, let's move on to the client. So as you can see, I've already created the 3 files we're going to be using in their respective folders. So within public, I've created the index.html file along with like a basic boilerplate template, as well as the index.js and styles.css files within the static folder. So let's actually get started with the index.html file. So right now, we just have a template given to us, and let's get started and filling in this template with with our code. So let's get started with the title, and this is sort of the text that shows up like in the tab of the web page. So let's just name it like Image Classifier Web App Workshop and close that title. And from here, we're going to copy over 2 links. So one is for Bootstrap. It's a pretty long link, so I'm just going to copy it over. You can find it on the Bootstrap website. The second link is a link to the styles.css file. using like a syntax that's specific to Flask. So that's just going to specify that we're using the style sheet in the static folder. So let's copy it over. And generally for this part of the workshop, I'm going to be copying over more things because a lot of them are links and I don't want to type out everything and then have it be wrong and have to figure out what exactly is the error. So yeah, just going to copy over some things, especially the links. And next up is the body. So for the body, this is actually where all the stuff you can see on the web page is going to be located. So let's first get started with like the title. So if you remember in the demo, there was like a big line of text that like said like image classifier web app. Let's create that. So we're gonna wrap it in a div first of all. So it's good to wrap everything in divs when you're doing like front end design. And let's give it a class name of let's say like text, for example. Alright, so let's close that div, and then within that div we're going to make an h1, and let's call that text image classifier for handwritten digits web app, and then close that h1. Alright, next step is the canvas, but let's first write a comment here to let us know it's the title. Alright, next is the canvas. So we're also going to wrap this in a div, and for this I'm also going to copy over a little snippet just because it has a lot of like styling in it that's sort of annoying to copy over myself. So I'm just going, or type out myself, so I'm going to copy it over and I'll explain what exactly everything means. So here is a canvas tag. So we're giving it an ID of canvas, a width of 400 and a height of 400. And here's some styling, inline styling. The border is 4 pixels solid. The border radius is 5 pixels. We're going to specify the cursor's crosshair, and then margin auto, padding 0, and display block. I think these 3 things are going to help center the canvas in the middle of the screen. Alright, so now that we're done with that, let's go ahead and create the next part, which is going to be the buttons as well as the output text. So yeah, this is a very simple web app or simple front end. Just 3 things. We're going to have like the title, the canvas, as well as the buttons and the text. It's nothing really too complex. So let's also wrap this in a div, and let's actually wrap it in the same class of div as the title. And this way we can sort of keep consistent with the styling both in the title as well as here. So let's also give it a class name of text and close that div. And then here we're going to use a p tag to wrap the buttons that we're using, just so that the buttons appear side by side. And for this, we're actually going to use bootstrap buttons. So with that, there's something specific you need to add in the class tag, which I'll get to in a few seconds. But first, let's create an input of type equals button. And then let's create this ID and specify it as predict button. And then here's the class I was talking about. So the class for bootstrap buttons, we need to make sure this class is this specific class. So btn primary. This just lets us know that, or lets Bootstrap know that we're using their button. And let's go ahead and give it a value, which is the text that's going to be showing up for the button. So we want the button to say predict, and then style, let's give it nothing. All right. So that's our first button, and our second button is going to be very similar to that. So let's actually just copy this and give us clear button instead of predict button, and same type of button, and then the text is going to instead say clear canvas. So this is going to be the clear canvas button. And right now, these buttons don't actually have any code associated with them, so they're not going to be doing anything when you click on them. But we're going to be implementing that in the index.js file to give those buttons functionality. And next, we're going to be creating an H1 that represents the text output of the predicted value that the server will send back to the client. And let's call this H1 with an ID of result, and then create 2 span tags, and then close the H1. And right now it's empty, but it will be filled with scripts that we will write that will conditionally render the text within this tag. All right, so now that that's done, we can go ahead and copy over more scripts or more links to dependencies for our scripts. So like I said, we're using jQuery and we're using Ajax, so we need to go ahead and copy over those things. So there's 3 links that jQuery requires, and they're on the jQuery website, so if you want to just use that and find that there, you can. But otherwise, here are the links I'll be using. And those are the dependencies for jQuery. So let's just call this dependencies and scripts as a comment. And then below here, we're actually going to go ahead and write the script, the JavaScript for the post request to the server. So let's create a script and type equals JavaScript, and let's close that tag. Oops, I messed up the spelling. Okay, and let's give us some space for that. So let's use jQuery, and then remember we have this predict button right here, right? So with this ID, we want to write a script that whenever this button is pressed, so let's specify this button, so predict button. Whenever this button is pressed, so dot click, we want to sort of create a special function for it. So on click, let's create a function, and then let's actually move this over here. A special function for this, and then in this function, let's do some variables. So the first variable is something that is required for Flask. So we're getting the script root, and we're going to set that equal to I think request dot script underscore root, and then this vertical line, and then safe, and then this is something that is required if you're using a request in Flask. So we get that script root, and then from here, let's specify the canvas that we're using. So canvas object, and then use document.getElement by ID. And because we name this canvas with an ID of canvas, we can just type in canvas, and this canvas object now represents that canvas. So in order to get the image from the canvas, we're going to create first a variable called like img, and then we're going to set it equal to our canvas first, and then this function called toDataURL. And this is going to take whatever's on that canvas and then transform it into a URL. And so this URL has two parts. So the first part is going to have something, like semicolon base64, and then it's going to have that image encoded in base64 right after it. But we don't really care about the first part. So what we want is actually the second part of that data. So everything after the semicolon base64. So just to show that sort of pictorially, it'll be like something like, for example, like canvas slash like base64, and then it'll be like a bunch of like text that's like base64, right? So it's not going to really be legible. But we only want everything after this little tag here. So what we can do is we can get this data and then use this function called split. So what split does is it takes a string, and then given a certain string delimiter, it's going to split that string based on every instance of that delimiter into an array of strings. And each part is going to be tokenized based on whenever it finds that delimiter. So because we're only splitting on, I think we're splitting on base64, this semicolon base64, the first part is going to be like some data representing like the name of a canvas, for example. And the second part is going to be everything after that base64, which is all of the information of the image that we want. So because of that, because it returns an array, we want to get everything after base64. So we want the second part of that array. So we want to index into that array and then index into the first index, which is the second element of the array, because these arrays are zero indexed. So we get that image data, and then we go ahead and call Ajax and use this to create a post request. Let me just fix that real quick. I think I want to create a bracket first. Yeah. And then specify a JSON object, and we're using the post method. Let's instead have a comma here. And then the URL, we're going to use the script root, variable we created, and then we're going to specify the endpoint of our server. So remember, we created a submit endpoint. So let's use submit here as our endpoint. Our data is going to be the data we're sending over, and we want to send over the image data we just created. And then on success, we're going to specify a function. And this function is going to take in this data, and then it's going to render the tag that we specified before, and then actually give it a value. So remember, we called this tag up here with an ID of result that's empty right now. But right here, we're going to specify that result, and then now we're going to give it text value. And then the text value, let's give it predicted output, and then append on the data. And this is actually a callback function. So what this does is it gets the data that's sent back from the server and then appends it on here. This is not actually the data that's within the same object. This is the data that the server sends back to the client. Okay, now that we have that, we're gonna close up everything, make sure it's aligned, and then that should be the script for the post request. Alright, so we're almost done with the front end, but a few things are left. So remember that although we've given functionality to this predict button through this JavaScript script that we've written, the clear button as well as the canvas, they still don't really have full functionality. So that is exactly what this index.js file is for. So before we do anything though, we want to make sure that we actually include that index.js script. So like we did with this link here for the style sheets, we can go ahead and do the same thing. So I'm going to copy over a script link, which is going to be sort of in the same format using this static file or static directory and file name syntax, and then instead use that for the index.js. And this is going to let us know that let the document know that we're using the index.js to give functionality through the script. All right. So for the index.js file, I'm actually going to go and copy over the pre-written code and then go through everything and explain on a high-level sense of what it does. And this is because a lot of this stuff is pretty much boilerplate, and it's something that you can find online, and it's also pretty lengthy, so typing it through would take a little while. So let me just copy it over right now. And so the first thing you can see is everything is wrapped in a function, one singular function, and here it's setting up like the canvas. It's giving or specifying the ID of that canvas that we gave to it in the HTML file. It's giving it the settings that we want it to. It's giving it event listeners for the mouse to let us draw on the canvas, and then on paint it's going to actually put the color onto the canvas. And there's also a debug function, and all it really does is create a clear button. So this debug name is sort of misleading, but it's using the ID of the clear button that we specified in the HTML tag or in the HTML file, and then giving it functionality with a onClick function, and all it does is just clear the canvas. So with that in mind, we can move on to the last part of the front end, which is the CSS file. So this part is going to be really short. The first thing we're going to do is give the body some padding, and this is pretty much all we're going to do is for this body give 5 rem of padding, and for this p tag right here, we're going to give it some margin. So let's give it margin of 80 pixels just so everything isn't cluttered up. And then last but not least, for the title div, or not title div, the text div, I should say, because it's including the title as well as this part with the buttons and everything. Dot text. Let's just give it some padding as well. We're going to use 3 rem and 1.5 rem. And then we're also going to align everything in the center so it looks a lot nicer. So text align center. And that's pretty much it for the CSS file. So overall, everything should be done in the front end. let's go ahead and test the functionality of both the server and the front end and actually run the web app. Okay, so now that we're done with all our code, it's time to move on to the most fun part of the workshop, which is going to be running our code, testing everything, and making sure everything works. So before we do that, there's one quick fix, and that is removing this extra slash here in the submit endpoint. If you recall, in the front end, we didn't actually have this. So I'm just removing that to keep everything consistent. But now we can go ahead and run our app script, which is going to set up the server. So let's run that. And wait for it to load. And here it's running on port 5000, as you can see. So on this local machine, obviously, since we specified the local host. So let's click on that link, and it should open the web app in a new window. So let me just drag that over so you guys can see. Okay, cool. Now let's test some inputs, shall we? So let's test like 2. Predict. Oops. And then 2 is the output. Let's try like a 4. We got a 4. And let's try something like a 5. There's a 5. And let's try like a 1. Oops. There's a 5. Model might need more training, but that's okay. So there's our web app, and that is the tutorial. Alright, so I hope you guys enjoyed this workshop. In this episode, we learned how to build a backend server to handle a Keras model using Flask. We learned how to use HTML and CSS to create a simple front end, along with the HTML drawing canvas, and JavaScript and jQuery to communicate information between client and server, as well as basic web app fundamentals and architecture. So, as always, thank you for watching, and I hope you enjoyed.